Students, we will discuss today some important questions and which are appeared in previous entrance exams. Students, we will discuss some expected questions from S block elements, the first A group and second A group, alkali metals and alkaline earth metals. Let us see the question number 1. Which statement is false for alkali metal? Option 1, lithium is strongest reducing agent. Yes, it's well known to you, and lithium among the first A group of elements, it is strong reducing agent. Coming to second, sodium is amphoteric nature is given, but sodium is actually alkali metal. Given as what sodium is amphoteric in nature? No. Coming to third, lithium plus is exceptionally small. Yes, lithium plus is smaller, we can consider that. And the fourth one, all alkali metals give blue solution in liquid ammonia. Yes, all the alkali metals soluble in liquid ammonia producing what blue colored solution. That is their specific property of alkali metals. But option 2 you take, sodium is amphoteric in nature, is it? How can it be? Alkali metals are strongly basic in nature, but the given as what sodium is amphoteric in nature, that is the false statement among the given options. So question number 1 answer is 2. Coming to question number 2, sodium thiosulfate is formed when NaOH is neutralized by sulfuric acid. No, NaOH and sulfuric acid react, you are getting sodium sulfate, no choice. And option 2, Na2S boiled with sulfur, you are not getting any Na2S on boiling with sulfur, you are not getting any sodium thiosulfate. Coming to option 3, Na2SO3 is boiled with Na2S and I2. And option 4, Na2SO4 is boiled with Na2S. Option 3 you see, Na2SO3 boiled with Na2S and I2. This particular is commonly known as Springs reaction. What is Springs reaction? Heating the mixture containing sodium sulfite, iodine and sodium sulfite. This particular mixture on heating, you will be getting what? Sodium thiosulfate. How you get the sodium thiosulfate? Check it. Sodium sulfite, right, Na2SO3 plus iodine plus Na2S. This particular 2 NaI on heating this particular, then you are getting the product. This particular product you are getting Na2S2O3. So this particular Springs reaction represents the boiling or the heating the mixture containing Na2SO3 and iodine and Na2S. So here question number 2, this sodium sulfite is boiled with Na2S and I2. That is the correct answer. For the question number 2, answer is 3. Question number 3, sodium forms Na plus and not Na plus 2 because what are the options given? Check it. Sodium contains only one electron in outermost shell. Second, first ionization potential is small and the difference in first and second ionization potential is large. And third one, radius of Na plus 2 is much smaller than that of Na plus. And none of this. Sodium forms only Na plus. All the first A group of elements are forming only unipositive cations. Na easily forms Na plus because first A group, the general electronic conflict is not 1s1. They can lose only first electron easily, but the losing of second electron is very difficult as the first IP to second IP. First IP to second IP, a large difference is there. First IP to second IP, large difference is there. After losing one electron, all the first A group of elements are gaining stable noble gas configuration. Therefore, losing of second electron is very, very difficult. That is the option number 2. You see, first ionization potential is small and the difference in first ionization potential and second ionization potential is very large. Therefore, for the question number 3, that second answer 2 is correct. Coming to question number 4. Question number 4. Sodium bunsenate to give. Suppose generally what option is given? Option number 1 is Na2O. Option number 2 Na2O2 and 3 NaO2 and fourth option Na3N. Na3N. Now sodium on burning in air, yes we agree, Na2O can be produced. But on burning at little higher temperature, Na plus O2 to Na, 4 Na plus stick, 4 Na plus O2 you are getting on burning, yes, 2 Na2O. On burning air, then this particular Na2O may be easily convertible into sodium peroxide. Take 2 Na plus O2 near about 300 degrees centigrade, burning in air, then there is a possibility of getting Na2O2 at higher temperature. Higher temperature burning in air, then there is a possibility of getting what? Na2O2. So far, sodium burns in air to give sodium peroxide, the main product. Therefore, answer is 2. Question number 5, KO2, potassium superoxide, is used in oxygen cylinder in spacecraft and submarines because it. Option A is given as absorbs CO2 and increases O2 content. Absorbs CO2 and increases O2 content. Second, eliminate moisture. Third, absorbs CO2 only. And fourth, produces O3. Now you see, whenever KO2 actually reacting with what CO2, producing what O2 content, increasing the O2 content. How? Take here potassium superoxide, KO2 plus CO2 gives rise to, you are getting K2CO3, take here 4KO2, 2K2CO3 balance it, 2K2CO3, then you are getting what? 2O2. Like this, potassium superoxide reacts with CO2, producing potassium carbonate, and again you are getting oxygen. So it removes carbon dioxide and increases the oxygen content. So for the fifth question, answer is 1. Say A.